In this video, we're going to talk about rational functions. And what are rational functions? Rational functions are functions that are quotient of two polynomials. So we have here p of x over r of x. So p of x is a polynomial and r of x here is a polynomial. However, there is a restriction. Our divisor or r of x should not be equal to 0 because any value over 0 is undefined. For example, 2x over 0. This is undefined. So our divisor or our denominator should not be equal to 0. And there is a restriction for a polynomial. A polynomial should not have negative exponent. And there should be no radical sign in the polynomial. And there should be no fractional exponent. Now let us proceed with solving rational equations wherein we are given the equation and our goal is to solve for the value of x. Our first example here is we have 7x plus 12 all over 4x plus 3 equals 2/5. So our first step will be determining the LCD. And to determine the LCD, we are just going to get the product of the denominators. And the denominators here are 4x plus 3 and 5. The LCD will be 5 times 4x plus 3. And after determining the LCD, we're going to multiply this to both sides of the equation. We're going to have here 7x plus 12 all over 4x plus 3 times 5 times 4x plus 3 equals 2/5 times 5 times 4x plus 3. After multiplying the LCD to both sides, we are going to simplify. So we can cancel this one because these are similar, because these are equal. And in our left side, there will be only 7x plus 12 times 5. And in our right side, we can cancel this two equal values. And our left side, we're going to have here 2 times 4x plus 3. And simplify it further. So distribute 5 to this one and 2 to this one. 5 times 7x is 35x. 5 times 12 is 60. 2 times 4x is 8x plus 2 times 3 is 6. And then we're going to combine similar terms. We're going to have here 35x and 8x and then 60 and 6. To combine like terms, we're going to have here 35x minus 8x. So this goes to the left side and the sign will be negative equals negative 60 plus 6. So this goes to the right side and the sign will be negative. And then simplifying it further, 35x minus 8x is 27x equals negative 60 plus 6 is negative 54. And we're going to divide both sides by 27 to solve for x. 27x divided by 27 and then negative 54 divided by 27. We're going to cancel this one and our final answer will be x equals negative 54 divided by 27 is negative 2. Next example, we have here number 2. First step is we're going to determine the LCD. In this example, if you're going to multiply this to x, the answer will be this one. So we can only have the LCD as x plus 4 times x. And then we're going to multiply this LCD again to both sides. And we're going to have here 4x plus 2 all over x plus 4 plus 3 over x times the LCD, we have x plus 4 times x equals 21 over x squared plus 4 x times x plus 4 times x. And then we're going to cancel similar values. In here, we're going to multiply this multiplier to each term of our multiplicand. So we're going to have here 4x plus 2 over x plus 4 times x plus 4 times x. Then plus 3 over x times x plus 4 times x. And our right side, because this is equal to this one, we're just going to cancel this 2. So the remaining value will be only 21. And in our left side, we can cancel this. So we're going to have here 4x plus 2 times x plus, we can cancel this one. And then we're going to have here 3 times x plus 4 equals 21. And then we're going to simplify it further. We're going to distribute this x to this. And here also, 4 times x is 4x squared plus 2 times x is 2x plus 3 times x is 3x, and then 3 times 4 is 12 equals 21. To solve for the value of x here, we can apply factoring, but we need to make first our right side be 0. So we're going to have here 4x squared plus 2x plus 3x is 5x plus 12. We're going to transfer 21 to the left side, so it will become negative 21 equals 0. Then we're going to combine this one, and we're going to have here 4x squared plus 5x. 12 minus 21 is negative 9 equals 0. Next, we're going to factor it out. So we're going to have here product of two binomials. So factor our first term, that is 4x times x. And then the factor of our last term is plus 9 and negative 1. So to make sure that we factor it correctly, the product of this one plus the product of this one should be equals to the middle term here. So 9 times x is 9x. 4x times negative 1 is negative 4x. 9x plus negative 4x is 5x. So this is the middle term here. So we factor it correctly. After factoring, we are going to equate both factors to 0. So that will be 4x plus 9 equals 0 and x minus 1 equals 0. After equating both factors to 0, we are going to solve for the value of x in each factor. So in here, we're going to have here 4x equals negative 9. Divide both sides by 4. And x will be equals to negative 9 over 4. And in the other factor, x will be equals to 1. So negative, we put it to the right side, it became positive. So in this function, negative 9 over 4 and positive 1. So to make sure if our answer is correct, we can substitute these values to the original equation and see if the right side is equal to the left side. And if they are equal and the values of x we solved are correct. Now we are going to proceed with graphing rational functions. And we are going to graph the function f of x equals 2x minus 1 all over x plus 3. First step, we're going to determine the asymptotes. And what are asymptotes? These are straight lines that are being approached by our graph, but the graph will never touch it or cross it. There are two types of asymptotes. The vertical asymptotes, that is the upright line, and the horizontal asymptote, that is the one that is lying. To determine the vertical asymptote, we need to equate the denominator to 0. So our denominator here is x plus 3. And we're going to equate it to 0. X plus 3 is equal to 0. And then solve for x. And x is equal to negative 3. So this is our vertical asymptote. So this is an equation of a vertical line. How about the horizontal asymptote? In determining the horizontal asymptote, we have here three cases, wherein we are going to compare the degree of the numerator and the denominator. A degree is the highest exponent of an expression. So if the degree of the numerator is lesser than the degree of the denominator, the horizontal asymptote is the y-axis, wherein the equation is y equals 0. And if the degree of the numerator and the denominator are equal, Then the horizontal asymptote is y equals a over b, wherein a over b is the numerical coefficient of the leading term. When we say the leading term, these are the terms that have the highest exponent in an expression. If the degree of the numerator is greater than the degree of the denominator, then no asymptote. But there is an exception here. If the difference of the degree of numerator and the degree of denominator is only 1, then there is an oblique asymptote. So let us determine the horizontal asymptote of our function. So if you're going to observe, the degree here is 1. And in our denominator, the degree is 1 because the exponent here is 1 and the exponent here is 1. But we don't need to write 1 because it is understood that the exponent is 1. If you're going to observe, the degree are equal. So we're going to have here y equals a over b. A is the leading coefficient of our numerator and the leading coefficient here is 2. And next, b is the leading coefficient of our denominator and the leading coefficient here is 1. So that is 2 over 1 or simply 2. So our horizontal asymptote here is simply y equals 2. So after determining the vertical and horizontal asymptote, we are going to graph this in our Cartesian plane. And those lines are we have here. So this is the graph of x equals negative 3. And this is the graph of y equals 2. So we graph these two asymptotes using dashed line. Next step is we're going to determine the domain and range. To determine the domain and range, we're going to refer to the asymptotes. Because in the domain, we're going to exclude the solved value of x. And in the range, we're going to exclude the solved value of y. So our domain here is the set of x such that x is not equal to negative 3. This means that the domain is any real number except negative 3. How about the range? Range here is the set of y such that y is not equal to, we have here 2. So this means that the range is the set of real numbers except 2. If you're going to observe, you have here negative 3 and 2. These numbers will never part of our function. Next step, we are going to determine the intercepts and zeros. What do we mean by intercepts? These are points wherein the graph will intersect the y-axis and the x-axis. So there are two types of intercept. We have x-intercept and the y-intercept. X-intercept is a point wherein the graph will cross the x-axis, and y-intercept is a point wherein the graph will cross the y-axis. To solve for the x-axis, we are just going to equate the function to 0, and that will be 2x minus 1 all over x plus 3 equals 0. And then we're going to solve for x. So we can cross multiply this one. We have here the denominator 1. 2x minus 1 times 1 is simply 2x minus 1 equals x plus 3 times 0 is simply 0. And then solve for x. Then simplify. Then let us proceed. We have here 2x equals 1. Divide both sides by 2. Then x will be equals to 1/2. So as we have said, an intercept is a point, meaning our x-intercept here is 1/2 and 0. So this is the solved value of x, and this is the y. How about the y-intercept? To solve for the y-intercept, we're going to let x be 0. So y-intercept is equals to 2 times 0 minus 1 all over 0 plus 3. Okay, after letting our x be 0, we're going to simplify. So this will be 0, and the remaining term in our numerator is negative 1, and then our denominator is 3, or this will be equals to 1 over negative 3. And we're going to express this as a point. So the y-intercept here is 0, negative 1/3. Okay, so those are the intercepts. How about the zeros? In determining the zeros, this is similar in determining the x-intercept because zeros are the values wherein the graph will cross the x-axis. So our 0 here is 0 is the set of 1/2. Okay, let us locate our intercepts in our graph. So we have here, this point is 1/2, 0. And this point is 0, negative 1/3. So those are the location of our intercepts. Okay, so for the last step, we are going to create a table of values because this will be our reference to determine the shape of the graph. In making the table of values, we are the one to identify the values of x. And after identifying the values of x, we're going to solve for the value of the function or f of x. To give you a clue in identifying the values of x, we can determine at least 3 numbers in the left side of our vertical asymptote and 3 numbers in the right side of our vertical asymptote. So in our case, we have here negative 8, negative 6, negative 4, negative 2, 2, 4, and 6. Okay, after determining these values, we are going to substitute these values of x to the function and then solve. Okay, and then after solving, we have here the values of the f of x. So we have here pairing, or we have here points. So these are points. So our first point here is negative 8, 3, 2/5. Next is negative 6, 4 and 1/3. Then negative 4 and 9, negative 2, negative 5, 2, 3/5, 4, 1, and lastly we have 6, 1, and 2/9. So these are points in our Cartesian plane. So we're going to plot these points to draw our graph. Okay, so we plot the points. This point is we have here. 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 And this we have here. This one we have here. And last point we have here. This is that point. And then after plotting the points, we are going to connect these points. And we have here. So if you're going to observe, the graph approaches the asymptotes but it will never touch it. Okay, so that is how to graph a rational function. Okay, again, in graphing a rational function, the function should be in its simplest form before we can graph. Okay, so that's all.